So now we need to move straight to the next one, which is determinants of matrices. So one thing is we need to understand how to find determinant of a square matrix. One thing is before you could find any determinants, that matrix must be a square matrix. That is either you have a 2 by 2 dimensional matrix, or you have a what 3 by 3 dimensional matrix, or 4 by 4. The highest you could see is 3 by 3, just within these two. So you can only find determinant of 2 by 2 or 3 by 3. Please take note. An example of 2 by 2 matrix, you are all familiar with that. That is, let's say you have 2, 4, 5, minus 3. This is a 2 by 2 matrix. So I can go ahead and find the determinant of this matrix. If matrix A is this, then we denote determinant of this matrix as det of A, det of A, or you write it like this. This is also determinant. Okay, and at the same time, we have this determinant. The formula is actually given as determinant of matrix A is actually given as 1 over, if it is 2 by 2, we know how it is. Then we find the adjoint, and that's all. But if it is 3 by 3, this is formula we use. I'm going to give it formula later. But take note, if it's 2 by 2, this is how to find determinant of 2 by 2 matrix. One thing is the determinant of this matrix is denoted as 2, 4, 5 minus 3. And then whatever you have to do here is very, very direct. Just put a positive sign here and a negative sign here. If it's 2 by 2, this is the process to follow. But if it is 3 by 3, you are expected to follow this formula. So I will give you the formula anytime soon. Okay? But let's deal with this first. So in this case, I said if you want to deal with any 2 by 2 matrix, if you want to find the determinant of a 2 by 2 matrix, you are expected to put a positive sign up here and a negative sign up here. You need to go ahead and multiply this way, plus 2 times minus 3, and that's what? That's minus 6. Do you understand that? That's minus 6. Then minus 4 times 5, and that's what? Minus 20. So therefore, the last thing we need now is to write out minus 6, then minus 20, and that's what? Minus 26. So the determinant of this matrix is minus 26. Another example, if matrix A is given as minus 1, 4, minus 3, 2, hence the determinant of this matrix simply implies put a positive sign and negative sign here, and then cross multiply. Or you multiply the left to right diagonal, you subtract the right to left diagonal from the left to right diagonal. That is plus minus 1 times 2, that's minus 2, and minus 4 times minus 3 is plus 12. So the determinant of this matrix is what? Is 10. So 2 by 2, the determinant of 2 by 2 matrix is very, very easy. But if you want to work with that of 3 by 3, it is totally different. For 3 by 3, let's say matrix A is equals to 1, 2, 1, 4, 2, minus 3, minus 1, 2, 3, minus 2. So then I want to find the determinant of this matrix. To find the determinant of this matrix, you need to use what we call the Laplace expansion. The Laplace determinant expansion. That is, you need to put a positive sign, you follow the same process, plus, minus, then. So we need to take note of this. Let me remind you, okay, for this one, this is not formula for determinants, it is for inverse of matrix. A inverse is 1 over determinant of that matrix times the adjoint. Sorry, please, this is for the adjoint. This is for the inverse matrix. If you want to solve any determinant of any 2 by 2 matrix, use this method. Just put plus minus and then you cross multiply. If it's 3 by 3, you need to follow this rule. Put plus minus plus and then use what we call the Laplace expansion. In the next video, I'll make sure I explain it clearly. Okay, you just have to pick this first one here, plus 1. Then you need to reduce this